Okay, please settle down, everybody. Okay, so to formally start our class, let's have a prayer first. Okay, so thank you, Lord, for this day. In this we ask, in your mighty name, amen. Okay, so before you sit down, let's have a song first to start our class with energy. Okay? Okay, so are you familiar with the song? 1, 2, buckle my shoe. 3, 4, shut the door. Are you familiar with that? With action, okay? Okay, very good. Okay, so let's start. 1, 2, buckle my shoe. 3, 4, shut the door. 5, 6, pick up sticks. 7, 8, lay them straight. 9, 10, you did it again. Okay, very good, everybody. So you may take your seat. So let me check your attendance, okay? So, Acuña, yes. Toledo, yes. Okay, perfect attendance. Very good, class. Okay, so I have given you assignment yesterday. Okay, so please pass it in front because I will be checking that while you are working with your activity. Okay, so please pass it peacefully, quietly. Okay. Are you excited with our new lesson today? Okay. So before we head on to our new topic, it's related to our other topic that we had discussed yesterday. And what was it? Yes, we had discussed what is rational numbers, what are examples of rational numbers. Okay, so what again, rational numbers? Yes, Christine. Very good. You are very cooperative yesterday. I know that you have understood well what are rational numbers. But to test your understanding, I would have 3 questions, and you determine what I will be writing in the board, what rational numbers it is. If it is rational numbers with like denominators or rational numbers with unlike denominators. Yes, this is easy, but this is very important. Are we good? Okay. Okay, so let me write the examples. If you want to answer, just raise your hand. Okay? Is this rational numbers with like denominators or unlike denominators? Yes, Rika. With like denominators. Okay, very good. Because, of course, they have the same denominator. The word itself, like denominator. So it's just easy, right? Okay. So how about this one? How about that? Yes, Jemima. Okay, with yes, unlike denominators, because of course the word unlike, they have unlike denominators. This is rational numbers with unlike denominators. Okay. And the last one. Oh. Yes, Helen. Yes, again, this is rational numbers with unlike denominators. Very good. I chose that as a motivational activity because it is related to what we are about to discuss today. Alright, so let's head on to our topic, shall we? Okay, so I'm very sorry, class, if you cannot see me clearly because it's daylight. Our presentation will not be clear to you. We are turning off the lights and closing our windows, closing the door so you can clearly see the presentation. Okay, so the important thing is you can clearly see the presentation and you can hear me. Okay, so can you hear me? Okay, so that's good. Okay, so our discussion on our topic for today is adding and subtracting rational numbers with like and unlike denominator. Okay, so those problems that I have presented to you earlier, you have correctly answered. Okay, so that's the problem would look like. So those were the examples of rational numbers with like and unlike denominators. Okay, so how do we solve it? Okay, so first let's tackle first and let's discuss first how do we solve rational numbers with like denominators. Okay, so here are the steps. So first, copy the denominator. This, what it would look like. We already know the parts of a fraction. So the upper part is the numerator and the lower part is the denominator. So simply copy the denominator. And the second, add or subtract the numerator. Okay, so if the problem uses addition, so you're gonna add. But if the problem uses subtraction, so you're gonna subtract. And then, this is a very important note, simplify the answer if possible. Okay, so if you would end up to an answer, so you're gonna make sure if the fraction or both the numerator and the denominator is divisible by any number or reducible or can be simplified. It's an important rule, simplify if possible. So these are the steps of adding or subtracting the right denominator. So it's the same, either you're adding it or subtracting it. So if addition, you're gonna add a numerator, and if it's subtraction, you're gonna subtract it. But in this case, since they have already the same denominator, you are not going to subtract nor add it, just gonna simply copy it. That would serve as the final denominator for your final answer. Okay, so in unlike denominator, how do we solve it? Okay, so these are the steps. Okay, so we have two ways of solving rational numbers with unlike denominators. So I'm presenting to you two possible ways in solving either adding or subtracting rational numbers with unlike denominators. So first, finding the equivalent fractions. So these are the steps. Find for the equivalent fractions from both fractions having the same denominator. So just like in the picture here, we're gonna first find the equivalent fractions of the original fractions. For example, this is 2 over 4 plus 1 over 3. So we're gonna find the equivalent fractions of both fractions. So these are the lists of equivalent fractions. That's it. Find for the fraction that have the same denominator. Okay, so that put in the box. Okay, so as you notice, they have the same denominator of 12. 12. Okay, so that will serve as the alternative fraction to be used in solving for the final answer. Second, repeatedly do the step of solving fractions with like denominators. So after finding the equivalent fractions of the original fractions, so you may now repeatedly do the step of solving fractions with like denominators, where you copy the denominator and then you add or subtract the numerator. Okay. The other way of solving rational numbers with unlike denominator is cross or butterfly method. So how do we do that? So multiply the denominator of both fraction. Okay, so we're going to multiply that And then multiply the numerator of the first fraction to the denominator of the second fraction and vice versa. Okay, so we're going to multiply that, the numerator of this side of the fraction and the denominator of this side of the fraction and vice versa. Denominator of this fraction and the numerator of the other fraction. And then add or subtract the answer of the multiplied numerator and denominator of both fraction. Okay, so after you multiply it, this one, we're gonna add or subtract the answer of the multiplied numbers. Okay, this will depend on what operation we are using. So as we are using the subtraction here, so we are also gonna subtract the answer of these multiplied numbers. And then last but not the least, just like the rule or the important note of adding or subtracting rational numbers with like denominators, also in this we're gonna simplify the answer if possible. So that were the steps of how we add or subtract rational numbers with like and unlike denominators. Let's head on to solving it step by step. So I'm gonna stop the presentation first because we will be heading on to solving or applying these steps, and we will be using our whiteboard. And now you can finally see my face. But I will be presenting again later after our step-by-step discussion for your individual activity and group activity because I have included it in my presentation. Okay, so let's start here. Okay, so let's head on first on how to add and subtract rational numbers with like denominators. So for the first two examples, let's use first the operation of addition. Okay, so let's head on to our first example. Okay, so there. Eyes on the board, everybody. Okay, so what was again the first step? Copy the denominator. Okay, so this will be the denominator of our final answer. Okay, so we have 6, and we have 6 as our denominator. Okay, so the second step, yes, add, because we are using first addition, operation of addition, we're gonna add the numerators. Okay, so 2 plus 3 equals to 5. Okay, so can we simplify it? No, so that would be, or this would be our final answer, 5 over 6. Okay, let's head on to another example class. There. Okay, so the first step, copy the denominators. And that was 5. And add the numerators. 3 plus 1, 4. Okay, can we simplify this? Okay, no. So this would be our final answer. Okay, so it's that easy, class. Let's head on to using the operation of subtraction. Okay, okay. Okay, so for our example, okay, there. First step, it's the same as adding. Copy the denominators. Okay, of both fraction. Okay, so step 2. So as we are using operation of subtraction, of course, we're gonna subtract. Okay, so 5 minus 3, that would be 2. Okay, so can we simplify this answer? Or is this reducible by any number? No. Okay, so that would be our final answer. Another example. There, okay. So again, copy the denominators and subtract. Subtract the numerators. 6 minus 2 is equal to 4. So is this reducible by any number, or can we simplify this? No, so this would be again our final answer. Okay, so in adding or subtracting rational numbers with like denominators, it's very easy, class, right? Okay. Okay, so I am happy that you find it easy. Okay, so now let's head on to adding and subtracting rational numbers with unlike denominators. Okay, so how do we do that? Okay, let's head on to that right now. Okay, so we have discussed that in order to solve rational numbers, which is fractions, it must have the same denominators. Okay, so what if they don't have the same denominators or unlike denominators? How do we do that? Let us not worry, because there is solution to anything, especially math. Okay, so in the presentation, we have two ways of solving rational numbers with unlike denominators. We have finding the equivalent fractions and the cross method or the butterfly method. Okay, so we're gonna do both ways of solving rational numbers with unlike denominators for you to have an option of how you love your answer to be solved. Okay, so let's head on to our examples. Okay, first let's do the cross method or butterfly method, because it's faster to do and we can just do it in the problem here. Okay, so what was the step in cross method? Okay, so we're going to multiply these, and of course this one also, and this one also. Our numerator here in the other fraction, and the denominator here, and vice versa, the numerator in our second fraction and the denominator of our first fraction. Okay, so it's called cross method because it's like a cross, and it looks like a butterfly. Okay, so let's have first the denominator. Okay, so we're gonna multiply both the denominator of our fraction here. 4 times 3 equals to 12. Okay, so second, multiply. Okay, 3 times 1, that would equal to 3. Okay, so as we are using the operation of addition, okay, so we're gonna add the answer of the multiplied numbers. Okay, so 4 times 2, 8. Okay, so this would equal to 8 plus 3, 11. Okay, we have the denominator. Okay, so is this reducible, or can we simplify this? No. Okay, so this would be our final answer. Okay, so let's see if in this problem, if we're gonna do the other way, which is finding equivalent fractions of both fractions, if we would end up to the same answer. So remember this, okay? So 11 over 12. Let's head on to that. Okay, so the same problem. Alright, so what was again the first step? Okay, let's find equivalent fractions of both fractions in the problem. And let's find the equivalent fractions that have the same denominators. Okay. So 1 over 4 and 2 over 3. Okay, so we're gonna multiply both these fractions into accounting numbers. from 1 and so on, but we're gonna skip 1 because any number multiplied by 1 answers to itself. Okay, so we're gonna head on to 2, 3, 4, and so on. Okay, so 1 with 2, 8. Okay, so there we have the equivalent fractions in our fraction here as the original fraction in our problem. Okay, so let's head on to 2 over 3. Multiply that by 2, before 6. Let's see if we have already found an equivalent fraction on both original fractions, 1 over 4 and 2 over 3, with the same denominators. Okay, so 8, is there any denominator 8 here? No. How about 12? Okay, we have 12 here. Okay, so now that we have already found the equivalent fractions of the original fractions, so we're gonna use this as alternative fractions that we're gonna use in solving the original problem. Okay, so let's head on to that. Okay, so repeat the process of adding rational numbers with like denominators. So what was it again? Copy the denominator, that would be 12, because they have the same denominator already. And of course, add the numerators. 8 plus 3 equals to 11. So can we simplify this? No. So this would be our final answer. So do you remember the answer of our cross and butterfly method? Yeah, so is the answer the same? Yes, it's 11 over 12, 2. So that is how we do both ways in solving rational numbers with unlike denominators. We have here another example. Okay, so again, let's first do the cross or butterfly method, okay? Multiply this, also this, and also this. Okay, so let's head into that. Okay, so 3 times 4, so it'll be 12. And 4 times 1, that would be 4. Since we're using the operation of addition, I'm going to put that here. And then 3 times 2, 6. So, okay, so we're just going to add this up. 4 plus 6, 10 over 12. Okay, so can we simplify this? Can we? Okay, so what number? Okay, say they are both divisible by 2. Okay, so then divided by 2, 45. 12 divided by 2, 6. Okay, so this would be our final answer, as we can't simplify it anymore. Okay, let's head on to finding equivalent fractions. Okay, so the same question. Okay, so let's find equivalent fractions in both original fractions in our problem. Okay, so this multiply by 2 and so on. This would be 2 over 6. Okay, so this is now our equivalent fractions in original fraction 1 over 3. Okay, so let's see if we can find an equivalent fraction of 2, 4 that would be having the same denominator with these equivalent fractions. Okay, so multiply this by 2, it's 4 over 8. Okay, so I will stop here because I've noticed that we have already found an equivalent fraction of both original fractions in our problem that have the same denominator, which is 12. Okay, so let's head on to solving this as an alternative fraction to our original problem. Okay, we have 4 over 12 and 6 over 12 are alternative fractions or the equivalent fractions of the original fractions in our problem. Okay, so as we have now the same denominator, simply copy the denominator and, of course, add the numerator. 6 plus 4 would equal to 10. Okay, so can we simplify this? Yes, they are both divisible by 2. And divided by 2, that would be 5. 12 divided by 2 equals 6. Okay, so can we simplify this again? No, so this would be our final answer. Okay, so who remembers the answer when we did the cross method? Okay, so are they the same? Yes, they are. 5 over 6. Okay, so understood, class? Okay, so I hope you are not lying because we're gonna go ahead into subtracting rational numbers with unlike denominators. Okay, so in subtracting rational numbers with unlike denominators, it's the same process as adding. The only difference is we're gonna subtract it. Okay, so again, we're gonna do both ways of solving it. Okay, so the cross and finding the equivalent fractions. Okay, so let's head into the examples. Okay, so we have here our problem. Okay, so just like what we did in the operation of addition, here we're gonna do first the cross or butterfly method. Okay, so we're gonna do the illustration. Okay, so we're gonna multiply this, this, and that. Okay, so 7 times 5 will equal to 35. Okay, so 6 times 5, 30. Okay, so as we are using now the operation of subtraction, we're gonna put that here, we're gonna subtract that, and 7 times 1, 7. Okay, so you might get confused. In cross method, we're gonna multiply this always. So we're not gonna depend on what operation used in the problem. Okay, so we're only gonna use this, or we're only gonna depend on the operation we are using if we have multiplied the numerator and denominators of both fraction. Okay, so understood? Okay, so 30 minus 7, that would be 23. Copy the denominator. Okay, so can we simplify this? No, so that would be our final answer. So again, remember the answer, class, because we're gonna find out if we would end up to the same answers. It's 23 over 25. Okay, so the same problem. List the equivalent fractions of our original fractions. Okay, so first, we're gonna head on to multiply it by counting numbers starting from 2. So this would be 12, 14. Okay, so these are the few equivalent fractions. Let's see if we're going to find equivalent fractions have the same denominator with these equivalent fractions in our fraction here, which is 6 over 7. Okay, so let's head into that. 1 times 2 would be 4, 10. Okay, so here are the list of equivalent fractions of 1 over 5. Okay, so are you noticing equivalent fractions that have the same denominators already? Okay, what? Yes, this one. with a denominator of 35. So again, we'll be using this as an alternative in solving for our original problem. Okay, so let's head into that. Okay, so there, we now have the same denominator. Okay, so just simply copy. And then, what operation are we using now? Okay, so subtraction. So of course, we're gonna subtract. 30 minus 7 would be 23. So is this reducible or can we simplify this? No, so this would be our final answer. Okay, so is our answer in the cross method same as this one? Yes, it is. Okay, very good. So another example and the last example before we head on to our activity. Okay, so we have 3 over 6 minus 1 over 4. Okay, so again, let's first do the cross or butterfly method. Do the illustration. Multiply that, multiply that, multiply that. Okay, so 6 times 4, 24. 4 times 3, 12. And depend on the operation there and multiply this. 6 times 1. Okay, 6. Okay, so let's subtract it. 12 minus 6, that would be 6. Okay, so can we simplify this? Yes, by 6. So that would be 1 over 4. So it's obvious that we cannot simplify it anymore. So that would be 1 over 6. So again, let's see if this answer is the same when we do the equivalent fractions. Okay. So is it again? Let's list the equivalent fractions and our original fractions in our problem. Okay. So multiply this by 2. This would be 6 by 12. So these are the equivalent fractions of 3 over 6. So let's find out the equivalent fractions of 1 over 4 if we would find out the equivalent fraction that have the same denominator with these fractions. Okay, so I think we now have the equivalent fraction of 1 over 4 have the same denominator already, which is this one here. Okay, so we're going to use that as alternative fractions for us to solve this problem. Okay, so now let's head on to subtracting. Now we already have the same denominator. Okay, so just copy that. And then later, and of course, subtract. 6 minus 3, that would be 3. So is this reducible or can you simplify this? Yes, we can. By what number? 3. Okay. So 3 divided by 3. 1 over 4 divided by 3 is 4. Okay, so to be our final answer, and it's the same as our answer when we did the cross or butterfly method. So that is how we add and subtract rational numbers with like and unlike denominators. So let's have a short summary of what we have discussed. So in adding or subtracting rational numbers with like denominators, we just simply copy because they have already the same denominators. We just simply copy, and if you are using or if the problem uses the operation of addition, we're gonna add. Or if it uses subtraction, then we're going to subtract the numerator. So your number one rule, simplify if possible. So in adding and subtracting rational numbers with unlike denominators, we have two ways. What are they again? The cross or butterfly method and finding the equivalent fractions. Okay, so that ends up our discussion and explanation on how we add and subtract rational numbers with like and unlike denominators. Okay, and one thing, class, if you are wondering, or if not, I would just say this. How about the decimals, ma'am? How about the whole numbers? Aren't they rational numbers too? How do we add or subtract those decimals? Why do we only include the fractions? Okay, so in our discussion yesterday, it has been said that rational numbers is any number that can be converted as or can be written as fraction. So those decimals, those whole numbers, if you want to add that up or subtract it, eventually you will end up converting or turning it into a fraction. And when you convert it into a fraction, you turn it into a fraction, there you may now do the sorting. Okay, I hope you're not confused to that, but if you didn't have any confusion, then that's good. But I am telling you this because you might question or you might be wondering why. Okay, so to test your understanding, if you have understood clearly our discussion or topic today, I have here problems that we need to solve. Okay, so please answer this in a 1/2 sheet of paper. I will let you answer this for 8 minutes. And after that, you will be checking your paper and head on to our group activity. Okay, so you may start now. Okay, so time is up. Please exchange your paper to your seatmate. Okay. So number one, who would like to answer? Yes, Jean. Okay, 6/5. How about number 3? Sheena. 3/10. Very good. Okay, so return the paper to your seatmate. Okay, so please pass your paper because I will be the one who will be recording that while we do the group activity. Okay, so please pass your paper quietly. Okay, thank you. Okay, so for our group activity, please count to 5. 1, 5. Okay, so please go to your respective group quietly. Okay, so this will be the problems each group need to answer. Okay, so I know this is quite a lot, but you would be working with your classmates. I know you can brainstorm ideas on how to solve it. Everybody, each members of the group, please cooperate for you to finish on time, and you'll be able to check your papers. Please be noted that answering rational numbers with unlike denominators, you can choose either the cross method or the equivalent fractions. Okay, so you can only choose one to manage our time. Please answer it in one whole sheet of paper. You may start now. Okay, time is up. I believe that everybody is already finished with their answers. Please exchange your paper to another group. Number 1, what would be the answer? Because numerator and denominator is the same, can be equal as 1. Very good. Lastly, number 10. 3/8. Okay, so very good. I will now stop the presentation here. Okay, so thank you for your cooperation. You may get back to your seat. Okay, so before we end our class, I will be giving you another assignment, which is you need to make a problem on your own, just like this one, and just like what the examples we had solved earlier, rational numbers with like and unlike denominators.
You need to solve it on your own and please don't copy the examples that we had in our discussion earlier.
You will be making two problems on both kind of rational numbers, two for like denominators and also two for unlike denominators. The other problem must use the operation of addition and the other one is subtraction. Understood? Okay, so all in all, you will be doing four problems, two for unlike denominators and also two for unlike denominators. Other one, you will be adding it, and the other one, you will be subtracting it.